I'm going to draw this one and we're going to predict the product here. Okay, so it had, oops, not there. Here we go. And then CH3, CH3, and it had H2SO4, and then I think it had, how did it draw it exactly? Plus water. Okay, I just want to make sure I have it exactly how they have it. Now the water, they have plus H2O, but technically they could have just put H2O right here. It means the same thing. These are all going in one beaker. Okay, so since there's no peroxide in here, then this is just a Makarnikov addition of OH and OH, so water, really. So let me draw. It's going to go across the double bond, so I'm going to draw everything. And then CH3. The double bond would have gone right here. Now I need to decide Makarnikov position. What's the most stable carbocation, if you want? Here, which would be primary, or here, which is tertiary. Okay, and that would be here, the tertiary carbon. So that's where I'll put my OH, and on the other side, I'll put my H. And that's the answer there. You asked about a tertiary carbon. So a tertiary is a carbon that would look something like this. Maybe something like this. And that just means it has 3 carbon groups coming off of it. 1, 2, 3. A carbocation would be, let me draw on skeletal. Okay. So here is a tertiary carbon right here. Now, it has a hidden hydrogen. Let's say we had a reaction and the hydrogen goes away. Okay, a base came and took it off. Now, if I one less group there, now that's a carbocation. A carbocation means you have one less group than what you started off with. So if you draw it and it's drawn neutral like that, that means there's a hidden hydrogen there. It's stable. Okay, a carbon always has 3 groups coming off it. In this case, it has a CH3, CH3, CH2. Okay, so it's a tertiary carbon. Okay, and then a hidden hydrogen there. So there's always 4 groups. Now, if it shows it with a carbocation, so if I draw the same thing, but now I have a positive charge there, that means it's missing the hydrogen. That hydrogen is gone. And now it's a tertiary carbocation. All right, now let me look at 11 for you. Let me come down here. Okay, so you have styrene. Now styrene's going to look like this. Oops, nope. Let me draw here. Is this gonna, no, it's not gonna let me draw. Okay, styrene would be here. Like this. This is called styrene. Okay, and it says in methanol was a mixture of HGOAC2 in methanol. So let's put that. So inside of here, we have methanol, which is just CH3OH, and then HGOAC2. With some sodium hydroxide followed by NaBH4. Okay, so we have then sodium hydroxide and NaBH4. Okay, then it dried, blah, blah, blah. Okay, so most of this you don't actually need. This is just showing you what it looks like when you have a chemistry paper, when you're reading an article. This is how it gives you the directions on how to make this, okay? Now, it wants to know what you're going to look at. It doesn't matter how much, how many grams, moles, milliliters, and then how long and the room temperature. For your case, it doesn't matter. What you want to know is what all did they put in there. So you're just finding the um, reactants, okay, which are what I have written here. Now this is just the Markovnikov addition. Now normally when we do this, we see the mercury and NaBH4, we add water. But instead of water, we have CH3OH. Now let me show you this. Water looks like this, okay? Methanol looks like this. Let's make it look like water. Okay, let me just draw it all over again. CH3OH. Notice the only difference between the two is this methyl. So water has a hydrogen, methyl has a CH3, okay? But it'll react the same. So whenever I add water over a double bond, I'm going to add OH and H, okay? So OH and, let me change my color here, and H. These are the two groups I'm going to add. In this case, I'm going to add, instead of OH, I'm going to add OCH3 and hydrogen. Okay, it'll always add like this. It'll always be OCH3 and hydrogen. So it's a Markovnikov addition. So here's where the double bond was, right here. So Markovnikov, what would be the most stable? On this side I have a primary, and on over here I have a secondary. The high, again, how many carbons you're attached to. So the secondary is going to be more stable, so that's where I add my OCH3 group, and on the other side I add my hydrogen. So that one's there. If you have any more questions, please let you know. There's 10 and 11, or if there's anything you're iffy on, please email me so I can, make another podcast or something. Anyway, good luck.